Hello, this is Mr. Henry, and welcome to Lesson 5.2. In this lesson, we're talking about special types of linear systems. In the last lesson, we solved systems of equations by graphing. In this lesson, we're still looking at graphing, but we're looking at how some other equations or how there are other solutions we might get. Okay, so the essential question says, how do I find the solutions to special types of linear systems? Did you know? If you have two straight lines, imagine like a long piece of yarn or like sticks of spaghetti or something like that, there are actually four ways these pieces of yarn could be oriented. You can lay them down on a table and make them parallel. You could make the two pieces of yarn cross each other, like they're intersecting. So we have parallel, we have intersecting. You could lay the yarn on top of each other, so they're essentially the same thing. So, like side by side or directly like this would be overlapping. Lastly, if you pick them up off the desk and hold them so they're not parallel, now that's going to be awfully hard with yarn, but with sticks of spaghetti, you could do that. These would be called skew. This word skew, as I'm showing here like on this grid, these two lines are not parallel. They're not intersecting. I mean, if you look at it and go, oh, wait, if you draw this guy down here, it intersects. No, you're thinking of like two-dimensional space. This is a three-dimensional grid. So this top corner of a box and this bottom corner down here. If you were to take those lines and extend them, they're never going to intersect each other. They're separated by the height of this box. So they're not going to touch or intersect. They're not parallel. They're called skew. So, parallel lines. Back in your vocab cards. We have one word, parallel. So most people know parallel, but you kind of have I'm going to call it a childish definition, which is, it sounds bad to say it that way, but it's not. Most people, when you hear parallel lines, you think, oh, they're two lines that don't intersect. People think of example of like railroad tracks. They're going the same direction side by side, which is all true. That's completely true. Now, for us, we're going to expand that definition a little bit. So it is two lines that do not intersect. But the new part here is they have the same slope. For two lines to not intersect each other, it means the slopes of these two lines are the same. So if this guy has a slope of 4/3, this guy would have to have a slope of 4/3. That's what it means to be parallel. They have the same slope. If I pull up my Desmos here, and I put in just y equals, I'm gonna do 3x plus 2, and y equals 3x plus whatever. Now, whatever number I put in next, 1. It's hard to see. 8. You can look at it and go, oh yeah, those two lines are clearly parallel to each other. If I zoom out and out and out, well, it looks like they're overlapping. It's just because at the zoom level, they don't intersect each other. They are parallel. Because if you look at it, their slopes are the same. If I change this guy's intercept to, say, 10, they're still parallel. Now, as soon as I change this 3 to something else, 2, boom. Now they're not parallel anymore. Now they've intersected each other. So parallel lines have the same slope. They're going the same direction. Alright, so this looks like what we finished off the last lesson with. We need to take these two lines, we need to graph them in the space provided. So I'm going to move them off to the side, just like I did before. I'm going to graph them and solve and all that good stuff. So let's do it. This one, like before, is already solved for us. This is our slope. This is our y-intercept. So this line has a y-intercept of 1, has a slope of negative 3/2. So I'm going to go down 3/2. Down 3/2. I can't do it anymore. Up 3/2 the wrong way. Wait a second. That's not a straight line. I think I messed him up. Down 3/2. Now that looks like a straight line. That's one way to check for mistakes. If you drew your dots and you see a dot that's kind of out of whack, it doesn't look straight, you might have just counted boxes wrong. I did. I went down 2 over 2. Should have been down 3 over 2. Okay, so I have this guy here. My other one, I'm going to solve. I'm going to start by trying to fix that horrible line I just drew. Better. Subtract 3x on both sides. 2y equals negative 3x plus 10. They cannot be combined together because they don't have the same variable. They are not like terms, so I just bring both pieces down. I then divide by 2 on both sides to cancel these y's out, and y is equal to negative 3 over 2x plus 5. Do you notice something? Slope, slope. It's the same slope, but a different y-intercept. So here, when it crosses at 5, 1, 2, 3, 4, 5, and I go down 3 over 2, down 3 over 2. The lines didn't intersect each other. Now, I'm going to draw the lines in here because it's going to make seeing this a bit more clear. So when I draw these lines in through the points, and now a red one, you see the lines are parallel. They're not getting closer, they're not getting farther away. These lines will not intersect. So if our job is to find where lines intersect, because that's when we learned in the last lesson, that's the solution to a system of equations. It's where the lines crisscross each other, what point makes both equations true. You're looking at this going, these lines don't intersect each other. You're right. So what's the answer then? Well, the answer is there is no solution. There is no point on this graph that will be on both lines, no matter what dot I put. There we go. So this dot, I can go anywhere I want on this line. It's never going to work for the red line. If I move the black dot to the red line, no matter where I put this black dot, no matter even if I extend it further down here, the blue line's never going to cross through it. So there is no one point that both lines go through, so there is not an answer to this system of equations. No solution. Letter B. I would like you to do this one. So you're going to take these two equations, you're going to solve them if you need to, graph them, please, and find the solution to the system of equations. Go ahead and pause the video. Do it right now. When you're ready to continue, hit play, and we will go through it together. All right, so let's see what we got here. This guy is easy. This guy is harder. So my slope is 2. My y-intercept is 4. 1, 2, 3, 4. 1, 2, 3, 4. Slope is 2. You're going, wait, I can't go up 2 over 1. Because that's my slope. Yes, but you don't just do that. That's going to be wrong. That's down 2 over 1. That's not what this says. So what I recommend you do is you go up 2 over 1. Put your little ghost dot up there. At least it gets you going in the right direction. At least you now know that your line looks like this. Okay? Now, we're going to go the reverse of that. Down 2 over 1 the wrong way. See? Straight line. Down 2 over 1. Down 2 over 1. We're going the wrong way. Now, if you start from the left and go to the right, up 2 over 1. Up 2 over 1. Up 2 over 1. Just like the slope says. Okay. Second one. I'm going to start by solving for y. So I'm going to get rid of the add and subtract first, the multiply and divide last. So I'm going to add 6x to both sides. These guys cancel out, and I get 3y equals, well, I can't combine them, so 6x plus 6. To get the y by itself, I'm going to divide by 3 on both sides. Cancels. Y equals 6 divided by 3 is 2x. 6 divided by 3 is 2. Looky, looky. My slopes are the same. 2x here, 2x here. They're going to be parallel. So we do it. Let's see. This guy has a y-intercept of 2. See? Slope is 2, up 2 over 1. I'm out of space. I do the reverse. Down 2 over 1 the wrong way. Down 2 over 1 the wrong way. And hopefully you can see they're parallel. You can see that they're going the same direction. If you can't see it, you can draw your lines in there. There's nothing wrong with that. There we go. My lines are parallel. They're not going to intersect. There is no one point that makes them both true. So these two guys have no solution. There is no one point that makes them both true, so the system of equations has no solution. Now, each individual equation has its own solutions. So, for example, this the red line is this one here. That point is a solution to this equation. That point is a solution to this equation. That would work here. That one would work here. All the points on the green line work on this other equation. But there's not one point that works on them both. Example 2. Now, the first two, we're dealing with parallel lines. This one here is, well, overlapping. So, first one is slope, intercept, crosses a y-intercept at 2, has a slope of up 1 over 2. Up 1 over 2. I'm out of space. I reverse it. Down 1 over 2 the wrong way, like so. Line. Second one. I'm going to start by solving for y. So I'm going to subtract x because he's positive. I'm going to subtract him. It is not minus x. It is a negative 2y. So I subtract x. I still have my negative 2y. But I also have a negative x and a minus 4. Both pieces just come along for the ride. I divide both sides by negative 2 to cancel him out. Boom, boom. Y equals. When I divide the other side by negative 2, here my negatives would cancel, and my fraction, the 1 over the 2, is just going to stay 1 over 2. It doesn't divide evenly, so I'm just going to leave it as a fraction. On this side, negative 4 divided by negative 2 gives me a positive 2 slope. Now, check out these equations. Check out the equation from part 1 here and the equation from part 2. What do you notice about them? Did you notice it's the exact same equation? Y equals 1/2 x plus 2? That's because it is. That's what it's going to look like for these equations that are overlapping. Like if I go to like graph, okay, I got that point, and I would do the exact same thing. These lines are literally the same line. They are on top of each other. So if I draw in my first line, which was green, right? So let's draw green in here. And then I draw in a blue. Let's see how good I am. There you are. They are directly on top of each other. It is the same line. They go to the exact same point. So if our job is to find out where do they intersect, where are these two lines, where would they have the same points that would work in both equations? Well, this point right here, oh, where's my marker? This point right here would make both equations true. This point right here would make both equations true. And this one. And this one. And that one. And that one. And that one. And that one. And every single point, because the line shows every answer to those equations. And since it's the same line, every single point is an answer. Okay? So if you're thinking back when we solved the equations, we had equations that had like all real numbers as a solution, and then we had no solution. Well, the same thing kind of happens with these lines. We saw what it looks like for if there's no solution for a system of equations. It's like this. They're parallel. Well, this is like the all real numbers. This, we say, has infinitely many solutions. So we don't say there's one solution. We don't say it's all numbers are solutions. Everything is not a solution. Okay, there are points that are not solutions. Him, he's not a solution. And what if he's over here? He's not a solution. Nope, 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 nope. Okay? So you can't say everything's an answer. But there's more than one. There's an infinite number. So we just say that this system of equations has infinitely many solutions. Every point on the line is a solution. Okay? Letter B. Copy the two equations down off to your paper. Go ahead and solve them and graph them, and it should be overlapping again. But double check just to make sure. Okay? Pause the video. Do it on your own. When you're ready to continue, hit play, and we'll go through it together. Okay. So 1 and 2. And you know what? I'm going to start the second one first this time. So I'm going to start here, and I'm going to start by subtracting x here and here, giving me 4y equals negative x minus 8. I divide both sides by 4 to get the y by itself. Cancel out those 4s. That was supposed to be a y. And we have y is equal to, let's see, negative x divided by 4. So that's negative 1x. That's going to give me negative 1 divided by 4x. And then negative 8 divided by 4 is a negative 2. Look at the equations. They are the same equation. I can right now say these guys are overlapping, which means they intersect everywhere. There is an infinite number of solutions. Infinitely many solutions. Now, to be a good little boy, we're going to graph, or boys and girls, we're going to graph so it crosses at negative 2. The slope is negative 1/4. Down 1 over 4. Can't really do that. Up 1 over 4. 1, 2, 3, 4. Up 1 over 4. And sure, we'll draw a line. Something like that. And the other one looks something like that. And it's the same line. That's why we only see one. Okay? So overlapping lines have infinitely many solutions because the solutions are everywhere along the line. So this little graph thing here is just to help, like a small graphic organizer, help keep these three different types of graphs separate. All right, so intersecting lines. So intersecting lines are just two lines that crisscross, right? Okay, so what things do we know about them? Well, we know they have one solution. Their solution is wherever they intersect. We know that they have different slopes. We know it has to have a different slope because if they have the same slope, they're either going to be parallel or overlapping. As soon as you see two lines have different slopes, that means that they're not going the same direction. They will intersect somewhere. Parallel lines. Parallel lines are two lines that are going the same direction. If I just copy paste, what was that? Copy, paste, there we go. So now it's the same line that's parallel to each other. So we know that these guys have no solution. We know they have the same slope. The slope's the same, they're going the same direction. But even though they have the same slope, they have a different y-intercept. And they have to. If they had the same slope and the same y-intercept, they'd be the exact same line. And that's the next one. That's overlapping. So these guys have no solution. They have the same slope. They have the same different y-intercept, so they never overlap. They never intersect. Last one, overlapping. So you got your one line here, and we change color, make them a little bit skinnier, and you got the next one there. Okay, so what do we know? Well, we know that these two lines, they intersect everywhere. I don't want to put everywhere, because I lie. It's not everywhere. Like, they don't intersect up here and there. So you got to be careful in your choice of words. So they intersect infinitely. Infinitely. There is infinitely many solutions. They are the exact same equation with the same slope and the same y-intercept. That's why they have the same equation, because the two parts of the equation are identical. Same slope, same intercept. It makes it the same equation, so it's going to be the same line. Okay? So now we have a little graphic organizer to help keep apart these three separate types of graphs. We know when they have one solution because the slopes are different. We know when they have parallel lines, which means no solution, if they have the same slope but a different intercept. We know if the lines are going to be overlapping because the lines have the exact same equation, so it's the exact same line. And I think we got 3 small problems left, and then we are done. Example 4 wants us to determine whether this linear system here has one solution, no solution, or infinitely many solutions. Okay. Now, the way we're going to do that is not by graphing. That would take too long to solve for y and solve for y and graph it to look at the graph. We can actually do it just by the equations. If we take both of these equations and we solve for y. For example, subtract 5x here, subtract 5x here, giving me y is equal to negative 5x minus 2. Now I know the slope and the intercept here. If this second equation has the same slope or the same intercept, then I can start making some decisions about what's going on. So I'm going to take this second one, and I'm going to solve for y as well. So I'm going to start by adding 10x, because we get rid of the add and subtract first. Negative 2y, don't forget about your negatives, equals 10x plus 4, not minus 4, plus 4. Divide both sides by negative 2. These guys cancel out, and y is equal to 10 divided by negative 2 is negative 5. Hey, same slope. 4 divided by negative 2 is negative 2. Hey, same intercept. So check out those two equations. What do you notice about them? They're exactly the same. They're identical. So because they're identical, it is the same line. Same line. Which means they overlap everywhere. Which means there's an infinite number of solutions. Wait, whoa, I missed a whole bunch of letters. Infinitely many solutions. Okay? There's infinitely many solutions because those two equations had the exact same equation when solved for y. They had the same slope, they had the same intercept, so it's the same line, they overlap everywhere. Infinitely many solutions. Letter B. This one's already done. That's my slope, that's my y-intercept. I can recognize that's already in slope-intercept form. So I just got to do this other guy. So I'm going to subtract 5x, because I get rid of add and subtract before multiply and divide, cancels. 3y is equal to negative 5x plus 6. Okay. Divide by 3 on both sides, and y is equal to negative 5/3 x plus 2. Okay. Let's examine our two equations. What's going on there? Well, they're close, but they're not the same. One has a slope of 5/3, the other has a slope of 3/5. Yeah, they're both negative. Negative 5/3 and negative 3/5. But that's not the same. They have different slopes. So in your head right now, imagine two lines with different slopes. So they're not going the same direction. They have to be going like that, which means they're going to intersect somewhere. So this has one solution. There is one solution to this problem. We don't have to find it. We just have to tell how many there are. There's one answer to that problem because they have different slopes. The lines are going to cross at one place. Last one. Go ahead and pause the video. Do this problem on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, let's see what we got here. First one is already solved. This is our slope. This is our intercept. I can tell because it's in slope-intercept form. So my slope is 2, my intercept is -4. This guy we're going to solve. So I'm going to start by adding 6x because I'm getting rid of the add and subtract before the multiply and divide. So 3y is equal to 6x minus 4. You cannot combine them together because they're not like terms, so you just keep them both separate. Divide by 3 on both sides, cancels. Y equals 2x minus, so that's 2, and that's -4/3, I guess. I mean, we could leave it like that. It's not so pretty, but it's not wrong. So there's the one. There's the other. Okay, so what do we notice about them? We notice that they have the same slope. So they're the slopes, the slanties are the same. We also notice that they have different y-intercepts. So where they're crossing the y-axis is different. So that means these are not the exact same line. Even though they have the same slope, they're parallel. They're not the exact same line. They're going the same direction, but they're separate from each other. So these guys are parallel. Parallel. Which means there is no solution. There is no place where these lines intersect each other. They do not cross. There's no solution. And for the solution. Question says, how do you determine whether a linear system has one solution, no solution, or infinitely many solutions? This has been lesson 5.2. Thank you for watching.